Imagine sinking below the last touch of sunlight, entering a world where ancient monsters never truly disappeared. We fear today's ocean, yet prehistoric seas operated on a far more terrifying, almost unimaginable level. For hundreds of millions of years, the deep sea evolved creatures that made nightmares seem ordinary. Many of those nightmare designs survived extinctions and still hide in depths humans rarely reach. To find their origins, we descend through ocean layers, leaving the bright surface for darker, stranger worlds. The sunlit zone reaches only 660 feet, holding most familiar marine life within its narrow boundary. Below it lies the twilight zone, where fading light reveals shadows, but no plants can survive. Deeper still is the midnight zone, a realm of permanent darkness where daylight never returns. Beneath that, abyssal and Hadal trenches plunge nearly 36,000 feet into Earth's deepest darkness. Pressure rises rapidly, 1 atmosphere every 33 feet, reaching more than 1,000 atmospheres in deep trenches. Without sunlight, photosynthesis stops. Deep zones hold no seaweed forests and no meadows of seagrass. Life endures using drifting marine snow, sinking carcasses, and energy from Earth's chemical vents. Most deep-sea creatures are soft-bodied, leaving little behind. Many bodies rot or dissolve completely. The fossil record here is incomplete, a history written on fragments, time nearly erased. For each fossil discovered, countless vanished species may have lived unseen and left no trace. Yet the surviving clues reveal a truth. The deep sea has nurtured monsters for 500 million years. Here, evolution pushed boundaries, creating giant eyes, eyeless bodies, and creatures glowing with living light. Among the most remarkable were ancient marine reptiles, diving hunters shaped like streamlined submarines. One reptile stood out with extraordinary eyes, the Jurassic ichthyosaur Ophthalmosaurus. It roamed the seas, once 150 million years ago, while dinosaurs still ruled the land above. Reaching nearly 20 feet long, it was built for speed, with a sleek body and powerful tail. Its enormous eyes, nearly 9 inches across, were among the largest of any vertebrate ever known. A strong sclerotic ring supported each eye, preventing collapse during deep, high-pressure dives. Scientific models suggest it could dive around 2,000 feet and hold its breath nearly 20 minutes. In the dim twilight zone, it hunted squid and swiftfish, guided by eyes built for collecting every photon. Such massive eyes helped Ophthalmosaurus detect faint silhouettes of prey rising far above in fading blue darkness. Squid and fast fish were its targets, hunted in deep water where few other reptiles could see anything. Its streamlined body and powerful tail allowed quick bursts of speed, essential for ambushing agile prey. Unlike many sea reptiles that stayed near sunlight, Ophthalmosaurus specialized in hunting deep beneath the surface. Across ancient Europe's seas, fossils show this deep diving lifestyle was not rare but truly widespread. But in the far north, another reptile pushed darkness adaptation even further, Ophthalmothule. This Arctic plesiosaur lived where winter meant months of total darkness beneath frozen seas. Its eye sockets were large, suggesting an ability to capture the faintest traces of light from above. Positioned upward, those eyes helped it track silhouettes of prey swimming overhead in Arctic gloom. Stones found inside its body cavity suggest it used them for stability during slow, patient ambushes. In this silent world, Ophthalmothule likely rose suddenly from below, striking prey before it sensed danger. These giants of the cold show how reptile evolution mastered not only depth but also eternal darkness. But deep night hunting reached another extreme in a much smaller predator, the mosasaur Phosphorosaurus. Unlike larger mosasaurs, this species was only about 10 feet long, tiny in a world of giants. Its forward-facing eyes created strong depth perception, similar to owls hunting in nighttime forests. This stereoscopic vision allowed it to judge distance precisely in dim, deep waters. Phosphorosaurus hunted glowing squid and small bioluminescent fish drifting through ancient Japanese seas. When giant mosasaurs rested near the surface, this little hunter began its nocturnal patrol. Its quiet movements and sharp vision made it a precise predator in the deepening night. It selected prey by watching faint flashes, tiny signals that revealed hiding animals in darkness. With a sudden burst, it rushed forward, jaws snapping before the glowing creature could escape. Phosphorosaurus shows that in ancient oceans, even small predators evolved extraordinary solutions for surviving the dark. Together, these reptiles reveal a world where darkness shaped bodies, senses, and entire hunting strategies. But reptiles were only the beginning. As we move forward in time, stranger deep-sea hunters appear. The next creatures did not vanish with prehistory. They still roam today, perfected by millions of years in darkness. As ancient reptiles faded from Earth's oceans, new predators rose in the deep, creatures shaped by darkness itself. One of the most terrifying is the viperfish, a hunter armed with teeth too long to fit inside its own mouth. Its fangs curve backward like hooks, designed to trap prey that cannot escape once bitten. Even when the mouth closes, those massive teeth stick outward because there is simply nowhere else to put them. If humans had teeth in this proportion, they would drag along the ground with every step. Viperfish hunt by launching their entire bodies forward, driving their fangs straight through unsuspecting prey. Their head joints act like shock absorbers, preventing their own skulls from shattering on impact. A glowing lure on their belly flashes softly, attracting creatures in the darkness without revealing the hunter. These predators have existed for tens of millions of years, barely changing because their design already works perfectly. But deeper still lurks another relic of prehistory, one that looks almost unreal, the goblin shark. With its long snout and pale skin, it resembles a sketch someone forgot to finish. But its most shocking feature is a jaw that shoots forward almost a foot to seize prey instantly. This slingshot strike is among the fastest feeding actions of any shark alive today. Fossils show goblin sharks have ancient relatives over 100 million years old, yet their body plan barely changed. Their success comes from stealth. Goblin sharks live deep, using darkness to hide until the perfect moment. When prey passes, the shark's jaw unlocks and springs outward faster than the eye can follow. This ancient mechanism proved so efficient that evolution simply kept it for millions of years. Yet, another survivor lurks below, one that looks as prehistoric as its lineage, the frilled shark. With its eel-like body and wide, frilled gill slits, it resembles creatures from the age of ichthyosaurs. The frilled shark carries over 300 trident-shaped teeth arranged in more than 20 rows. Its feeding strategy is simple. It lunges forward, swallowing prey whole, even those nearly half its size. For centuries, humans thought this species was extinct until fishermen found one alive in the 1800s. Its survival shows how the deep sea preserves ancient designs that vanish everywhere else. These hunters, viperfish, goblin shark, and frilled shark, prove the deep is a refuge for ancient predators. And the deeper we go, the stranger these survivors become, revealing evolution's wildest creations. Descending deeper, we reach creatures shaped by absolute darkness, animals with strategies stranger than any prehistoric reptile. Among them is the anglerfish, a predator whose survival depends on a glowing lure floating above its head. In pitch-black waters, this lure mimics drifting prey, drawing victims straight into the anglerfish's enormous jaws. But the strangest feature is its mating. Tiny males bite the female and fuse into her body permanently. The male becomes a living pouch of sperm, sharing blood and nutrients, a partnership lasting its entire life. This bizarre system evolved because finding a partner in the vast darkness is nearly impossible. Leaving the anglerfish behind, we journey downward to the ocean floor, where patience becomes a survival strategy. Here lives the giant isopod, an oversized relative of pillbugs, growing nearly a foot long in cold, high-pressure depths. Food is rare, so giant isopods wait months or years for a carcass to fall from above. When a whale or large fish sinks, dozens gather for a slow-motion feast lasting hours. After eating until they can barely move, they may not feed again for years. This feast or famine lifestyle allows giant isopods to survive in a world where food almost never arrives. But the deepest communities rely on a different power source, not sunlight, not falling food, but Earth's chemistry. At hydrothermal vents, superheated water rich in minerals bursts out, reaching temperatures near 700 degrees under immense pressure. Here live giant tube worms, animals with no eyes, no mouth, relying entirely on symbiotic bacteria for nourishment. These worms thrive because bacteria inside them convert toxic chemicals into energy, a process called chemosynthesis. Fossils show that ecosystems like these existed at least 430 million years ago, older than the first forests on land. Though modern tube worms are younger, their way of life echoes these ancient vent-dwelling pioneers. Around vents, life forms create bustling cities, surviving where no sunlight has touched for millions of years. These ecosystems prove that life can exist without sunlight, only chemistry and heat from Earth's crust. Leaving the vents behind, we rise slightly toward shallower ancient seas where a different wonder once flourished. These were forests, not of plants, but of animals called sea lilies, anchored to the seafloor like living trees. In Paleozoic oceans, sea lilies formed vast underwater fields, rising several yards above the seafloor. Some fossil species may have reached heights of over 60 feet, towering like underwater monuments. Though most vanished long ago, a few still survive in today's deep sea, unchanged in their elegant design. As ancient sea lily forests faded, another group shaped ocean floors for millions of years, the trilobites. Trilobites once had some of the most advanced eyes in early animal history, built from crystal lenses. But in deeper environments, several trilobite species abandon eyes entirely. The darkness made vision useless. These blind species survived by sensing vibrations and chemicals, navigating darkness with remarkable precision. Their success shows evolution sometimes removes features instead of adding new ones. Trilobites endured for over 250 million years, surviving multiple extinctions before finally disappearing. After their extinction, new ocean drifters emerged, animals stranger in shape but equally successful. Among them lived a bizarre ammonite, Diplomoceras, with a shell shaped like a giant 3-foot paperclip. Unlike spiraled ammonites, Diplomoceras bent its shell into a long U-shape for reasons still debated today. Chemical studies suggest this animal may have lived nearly 2 centuries, an extraordinary lifespan for a cephalopod. For 200 years, it drifted through Cretaceous oceans, while dinosaurs thundered across the continents above. Its slow life reflects an ocean where patience often mattered more than speed or strength. But long before ammonites evolved, oceans belonged to creatures unlike anything alive today. One of the strangest was Charnia, a 2-meter frond-like organism anchored gently to the seafloor. It had no mouth, no eyes, no organs, absorbing nutrients directly through its delicate surface. Charnia lived 565 million years ago, long before animals developed complex bodies or true predation. When its era ended, creatures like Charnia vanished completely, leaving no living descendants today. Even so, their fossils reveal a world where life explored forms we can scarcely imagine. After this quiet era, oceans transformed again as new predators rose and ancient lineages nearly collapsed. Some groups vanished forever, yet a few survivors endured, persisting through disaster after disaster. One survivor became legendary, a fish line believed extinct for 66 million years, only to reappear unexpectedly. In 1938, scientists realized the strange catch matched fossils of the ancient coelacanth. Thought gone with the dinosaurs, the coelacanth had quietly survived in deep, hidden caves. Its body plan changed little over millions of years, earning it the title living fossil. The coelacanth proves survival favors not only the fastest, but also those perfectly adapted to darkness. Coelacanths move slowly, using lobed fins like ancient limbs, remnants of a time when fish first explored movement on land. Their blood and tissues tolerate low oxygen, letting them rest motionless in deep volcanic caves. These ancient fish remind us that evolution sometimes pauses, preserving designs that still function flawlessly. But coelacanths are only part of the story. Deep oceans hide many survivors shaped long before dinosaurs walked Earth. Some modern predators mirror features from ancient seas, showing how darkness favors the same solutions across ages. In deep waters, eyes enlarge, bodies stretch, teeth lengthen, patterns that echo through 500 million years of evolution. Many deep species barely fossilize, meaning countless ancient monsters left no record for us to discover. For each animal we know, dozens more may have existed, vanishing completely into geological silence. This hidden history makes the deep ocean Earth's largest archive of things we may never understand. Even today, exploration captures bizarre creatures, beings with transparent bodies, glowing organs, or alien-like shapes. Some resemble ancient species, their bodies unchanged because evolution already perfected their roles. Others are completely new, proving the deep still invents creatures beyond our imagination. Each discovery reveals how little we truly know about the darkest regions of our own planet. The abyss covers more than half of Earth's surface, yet remains less explored than the Moon or Mars. Pressure, darkness, and cold create a world humans cannot enter without massive technology. Yet this hostile environment also shelters Earth's oldest lineages, living chapters from ages erased elsewhere. From ichthyosaurs to anglerfish, from trilobites to coelacanths, the deep preserves evolution's strangest creations. Many adaptations repeat across time: enormous eyes, hidden jaws, glowing organs, and bodies built for silent ambush. These recurring patterns reveal a simple truth: darkness pressures life towards similar solutions, no matter the era. And if these creatures survived unchanged for millions of years, what else might still hide beyond our reach? The deepest trenches remain almost unexplored, visited only by a handful of missions in human history. Each descent reveals new species, reminding us that the ocean still writes its story faster than we can read it. Prehistoric oceans are gone, but their monsters endure, some fossilized, others still swimming in the dark today. Their survival warns us: the greatest mysteries of Earth lie not in the stars, but beneath the waves. And as we continue exploring, the deep ocean may reveal creatures stranger older, and more incredible than we can imagine. Deeper than most hunters dared to roam lived a strange reptile, the abyss-going Abyssosaurus. Unlike fast-swimming reptiles, Abyssosaurus carried unusually heavy bones, helping it sink steadily into great depths. These dense bones acted like natural weights, allowing the animal to live permanently far below sunlight. In this silent, pressure-filled world, Abyssosaurus likely hunted by conserving energy and striking only when prey wandered close. Its thick skull and reinforced ribs suggest a body adapted to crushing pressure and near-freezing temperatures. Unlike shallow water reptiles, Abyssosaurus likely spent most of its life in darkness, rarely returning to the surface. Its world held no plants, little food, and temperatures that would kill most marine animals instantly. Yet Abyssosaurus endured for millions of years, proving some creatures thrive in environments we find impossible. Its existence shows the deep ocean was never empty. It was filled with specialists built for extremes. Even today, modern deep-sea creatures mirror Abyssosaurus' strategy: slow movement, dense bodies, and patient ambush. At great depths, speed becomes useless. Survival belongs to animals that wait, conserve, and strike with that precision. Many deep species grow heavier bones or oil-filled bodies to maintain stability in still, heavy water. Others evolve slow metabolisms, letting them survive long periods without food or movement. Some rely entirely on darkness, using sensitive hairs, pressure sensors, or electric fields instead of sight. Deep predators often attack upward, striking silhouettes of prey that swim unknowingly above them. In this realm, light becomes a weapon. Many creatures create bioluminescence to lure, mislead, or communicate. Some lights appear gentle, drifting like stars, but they often belong to deadly hunters waiting nearby. At greater depths, nearly every creature glows, blue, green, or even red, each color adapted to a specific purpose. Some use glowing lures to bait prey, others flash to startle predators or communicate during courtship. In this extreme darkness, every photon matters. Animals sculpt their bodies around the tiniest traces of light. Some creatures, like deep-sea shrimp, can even spit glowing clouds to confuse attackers. Others retain ancient traits, heavy bones, slow metabolisms, and silent behaviors that echo prehistoric oceans. Together, these adaptations reveal a rule: the deeper the ocean, the stranger life becomes. At extreme depths, survival demands creativity, strategies shaped by pressure, darkness, and a world without boundaries. Abyssosaurus and its modern counterparts prove the abyss is not lifeless, but ruled by specialists evolved for extremes. As we descend even deeper, familiar shapes begin to disappear, replaced by bodies sculpted entirely by darkness. At these depths, eyes often shrink or vanish. Sight becomes useless when no light survives. Many species navigate with pressure sensors, detecting subtle movements from meters away without ever seeing their prey. Some fish develop elongated fins, acting like antennas, reading currents and vibrations in the absolute dark. Others adapt by slowing their heartbeat, conserving every drop of energy in a nearly foodless world. Among the strangest is the barrel-eye fish with a transparent head, revealing its rotating tubular eyes. These upward-pointing eyes detect silhouettes of prey above, while the fish itself remains hidden in darkness. Its transparent dome protects the eyes from jellyfish stings as it steals prey from drifting siphonophore colonies. Few fish better demonstrate deep-sea innovation, turning their skull into a window for the world above. Deeper still lives another lineage, the ghost sharks, or chimeras, relatives of sharks older than dinosaurs. Their smooth bodies and wing-like fins glide silently through darkness, using electroreception to find buried prey. Their lineage dates back 300 million years, surviving changes that erased most of their ancient neighbors. Deep waters also compress gas-filled organs, forcing many species to lose swim bladders entirely. Without bladders, they rely on heavy oils, waxes, or gelatinous flesh to maintain buoyancy. Some appear ghost-like, transparent muscles, weak bones, and bodies collapsing if brought to the surface. Extreme pressure is a master sculptor, shaping life into forms impossible in the sunlit world above. In these depths, evolution favors softness, flexibility, and slow movement over muscle and speed. Some animals glow red, a rare color at depth, because most deep creatures cannot detect red wavelengths. Glowing red makes them invisible to predators while still lighting their own ambush. Others use bioluminescent organs like headlights, scanning the seafloor for movement in the dim silence. Dragonfish even fire red lasers from their eyes, an invisible spotlight for hunting unseen by their prey. These adaptations reveal a battlefield where evolution arms its warriors with tools beyond anything known at the surface. Here, survival comes not from strength but from ingenuity, an endless race of invention beneath crushing darkness. The deeper we travel, the more each creature feels alien, shaped by pressures no land animal could endure. And still, we have not reached the end. Below awaits a world colder, darker, and stranger than everything above. We now approach the Hadal zone, depths so extreme they represent less than 1% of the ocean floor. These trenches plunge over 36,000 feet, deeper than Mount Everest is tall. At such depths, pressure exceeds 1,100 atmospheres, enough to crush submarines not built for the abyss. Temperatures hover just above freezing, and total darkness persists year-round without a single ray of sunlight. Here, life survives only through extreme biochemical strategies, cell membranes built to resist crushing pressure. Hadal creatures often possess soft, gelatinous bodies that cannot withstand the low pressure at the surface. One remarkable inhabitant is the Hadal snailfish, thriving at depths beyond any other known fish. Its body lacks heavy bones, relying instead on light cartilage and special proteins to prevent pressure damage. Snailfish feed on tiny crustaceans living among rocks, using suction mouths to pick prey delicately. Surprisingly, these fish are not sluggish. They swim actively, proving life can flourish even in extreme darkness. Below them lie sediments that have not seen sunlight for millions of years, an untouched archive of ancient Earth. Microbes live within these sediments, surviving on chemical reactions alone, untouched by the world above. These tiny organisms may resemble early life on Earth, offering clues to how life began in ancient oceans. Exploration vehicles occasionally spot amphipods, shrimp-like animals, adapted to pressure levels unimaginable to humans. Their bodies contain special molecules preventing proteins from collapsing, a biochemical shield against crushing forces. Scientists studying these trenches believe similar biochemical tricks may exist on icy moons like Europa or Enceladus. The Hadal zone may hold Earth's best analogues for alien ecosystems hidden beneath thick planetary ice. Strangely, the deeper we go, the more familiar patterns of ancient evolution reappear. Soft bodies, glowing signals, patient hunting. It's as if the deep ocean has been following the same evolutionary script for 500 million years. These repeated designs hint at universal rules, solutions nature chooses whenever darkness and pressure dominate a world. And every new descent reminds us, we are barely scratching the surface of the planet we call home. The trenches hold landscapes more alien than any desert, mountain, or forest on Earth. Here, life has no sunlight, no seasons, no surface noise, only pressure, cold, and endless dark. Yet despite these extremes, organisms persist, thriving in conditions that would kill humans instantly. These survivors suggest an unsettling truth. Earth's deepest life forms may be the most ancient and the most enduring. These ancient patterns reveal a chilling idea. The ocean's deepest creatures may resemble life from Earth's earliest ages. The abyss holds designs untouched by time, creatures shaped before forests grew or insects took flight. But most deep-sea animals leave no fossils. Their bodies dissolve instantly, erased from the geological record. This means for every fossil we discover, countless other species may have lived, vanished, and left nothing behind. The ocean hides more history than all continents combined, stories waiting silently beneath crushing darkness. Even modern expeditions reveal new species almost every dive, proving the ocean remains Earth's last true frontier. Some discoveries defy expectations: transparent predators, gelatinous giants, and organisms glowing like drifting galaxies. Creatures like siphonophores stretch over 100 feet, forming colonies more complex than many single animals. Others drift like ribbons of light, using bioluminescence to communicate across distances unseen by any human eye. The deeper we look, the clearer the message becomes. Life adapts endlessly, even in the harshest places imaginable. These adaptations echo across time, connecting prehistoric oceans with the modern abyss in one continuous story. From ancient reptiles with giant eyes to modern fish with transparent skulls, darkness shapes evolution repeatedly. And still, most of the deep remains unexplored, over 80% untouched by human observation. The unknown below us could hold creatures stranger and older than anything in the fossil record. Perhaps whole lineages survive silently, hidden where pressure protects them from time and extinction. The deep ocean, once a prehistoric battleground, is now a sanctuary for life untouched by the modern world. Here, ancient designs thrive while surface species rise and fall through eras of change. The ocean's depths are not just dark, they are a living museum, preserving Earth's oldest evolutionary experiments. And the strangest truth is this: the deep sea we know today is still not the deepest life can go. Beneath the deepest trenches may lie habitats untouched, holding creatures shaped by pressures beyond imagination. If such beings exist, they may be the closest relatives to Earth's earliest animals. Prehistoric oceans may be gone, yet their monsters still roam, timeless shadows drifting in the planet's darkest places. These creatures remind us that Earth's greatest mysteries lie not in space, but below the waves we overlook daily. The ocean's oldest story is still being written, one discovery at a time, in silence miles beneath our feet. So what waits in the deepest darkness today? Perhaps creatures stranger than anything we've ever imagined.